All right, guys, we've got quite a bit that we need to cover today. So we're going to go pretty quickly through the bell work. We talked yesterday, when you see the word inverse, what does it mean to do? Guys, phones down, eyes up here. When you see the word inverse, what does it mean to do? Switch x and y. So on number 4 right here, this is going to become x equals negative 4 y squared plus 3. After we switch x and y, we need to isolate y. We got a whole bunch of stuff going on over here. I'm going to have to get rid of the negative 4. I'm going to have to get rid of the squared. And I'm going to have to get rid of the 3. And I have to make sure that I do this in the right order. When we are trying to isolate or solve for a variable, we have to go backwards through the order of operations. Guys, up here, this is important. That can wait. So again, we're trying to isolate y. So I'm looking only on the side where y is. First thing I'm going to ask myself is, do I see any addition or subtraction on the side where y is? Plus 3. We have to make that cancel. So minus 3 on both sides. We need to eliminate that piece so that we can isolate y. So I have x minus 3 equals negative 4 y squared. So I've gotten done with the addition or subtraction step. Then I move right here to multiplication and division. Again, I'm trying to isolate y, so I'm looking over here where y is. Is there any multiplication or division happening there? Yeah. Yes, what's happening? Negative 4 is being multiplied by the y squared, so I need to make that cancel. I need to get rid of it by dividing both sides by negative 4. So this would be negative 1 over 4x plus 3 over 4 equals y squared. Or you could write that as negative x plus 3 over 4 equals y squared. All right, so now we've done the multiplication and division step. Now and only now am I allowed to touch any exponents. Do I have an exponent around y? Yes. Yes. What is that exponent? 2. It's a squared. How do I undo something that's been squared? Square root. And if you do it to one side, have to do it to the other side. Squaring and square roots cancel each other out, but when we take a square root, we get how many answers? We get 2. Tell me about those 2 answers. Positive and negative. That happens anytime we have an even index. So I could write, this is my answer, or I could have y equals plus or minus the square root of negative x plus 3 over 4. Or if I wanted to get real fancy, I can simplify that denominator because I do know the square root of 4. What's the square root of 4? 2. So any of these would be correctly written final answers. Is that a function? In any one of those 3 forms, is that a function? Yes. No, why not? Square root isn't the problem, but it's because of the square root that we have a problem. What's in front of that square root? Plus or minus. Plus or minus. So because of this, it is not a function. When we have plus or minus the square root, Positive square root is up on top like this. Negative square root is down on bottom like this, and that is not a function. So when I include both the plus and the minus, it is not a function. Again, anytime we have an even index on our root, we're going to run into that problem. So square root, fourth root, sixth root, eighth root, 10th root, anytime the index is an even number, we have the plus minus, and the inverse will not be a function. Talk to me about number 5 now, the second problem on the bell work. What's the first thing I need to do because I'm finding an inverse? Switch the y and the x. So this becomes x equals 3y to the 5th. We're trying to isolate y. So again, I have to walk backwards through the order of operations. Is there any addition or subtraction next to the y? Nope. What about any multiplication or division next to the y? Yes, we do have that. There's multiplication happening right here. So I have to divide both sides by 3. That would be 1/3 x equals y to the 5th. There wasn't any addition or subtraction. I've gotten rid of the multiplication. There was no division. I'm now allowed to get rid of exponents. Do I have an exponent around y? Yes, I have a 5. If a square root got rid of a squared, what will get rid of a 5th? Yes, 5th root. So I do a 5th root on both sides. Exponent of 5 and the 5th root will cancel out. So I have y equals, do I need a plus or minus in front of this? No, why not? It's not that it didn't have a plus or minus before. This one didn't have a plus or minus with it, but we put it there. Yeah, but that's not why the plus minus ended up over here. Why did the plus minus end up over here? What kind of root did we take? A square root. So the index was 2, which is an even number. What's my index over here? 5. Is 5 an even number? No. Then I don't have the plus minus. Plus minus is any time my index is an even number. If it's not an even number, then I don't need the plus minus. So would that one be a function?
No. Yes.
Yes. Why? What's different about this one versus the other one?
That one has the plus or minus outside, so this is not a function.
That's exactly right. When we have the plus minus in front of it, it's not a function. If I don't have the plus minus, then it is a function. All right, I need you guys to pull out those 8-1 notes from yesterday. We started talking about graphing yesterday. We are going to learn how to graph logarithmic functions, and we're going to practice graphing several logs. And then we're also going to practice how to write an equation from a graph. All right. This table over here. This is an exponential table. How do I know it's an exponential table? It has an exponent on it. What is my base over here? Base is 2. So this is an exponential table. We learned how to make exponential tables in Module 7. Do you guys remember how we were getting these numbers on the y side when we did our exponential tables?
Yeah.
Yep. What was the base again?
2x.
The base is 2, and then we take it to the power of x, so 2 to the negative 3, and that's how you get 1/8. And then to get the next one, we take the same base to the power of the next x, which was negative 2, and that's how we get 1/4. Take our base to the power of the next x, which was negative 1, and that's how we get 1/2. Take our base to the power of the next x, which was 0. 2 to the 0 power is 1. Base to the power of whatever x we have over here is how we're getting our y values. And again, this is the base. So that's why it's a 2 all the way down, because we had a base of 2 right here. And we graphed these in Module 7. This is an exponential graph. Yesterday, one of the things that we learned is that a logarithm is the inverse of an exponential. This is the inverse of an exponential. I want you to look at the table for the exponential and tell me how you can use this table for the exponential to get the log table. No. How do you use this table right here to get the log table? You flip it. What are we switching? The x and the y, just like we did on the bell work. This is the inverse, so we switch the x and the y columns.
The question I have is, will it be rotated over x-axis or y-axis?
Neither. It's actually reflected over this line, y equals x. So it is a reflection, but it's not over x or y. So the log table switches the numbers in the x and y columns. Did the x and the y, did those letters trade places? No. X is always our left-hand column, y is always the right-hand column. But the numbers in those two columns switched places. So this green graph over here, this is the log graph. And it reflects over the line y equals x. All right. We are going to make our own log table now. Really? Because we are going to learn how to graph logs. So looking at this, if I have my exponential table, what do I do to get the log table? Flip it. All right. Let's try it. What is the base on this log? 3. So So I'm going to do an exponential table over here. With a base of what? Yes, with a base of 3. So x on this side, y on this side. We get to pick our x's on the exponential table, right?
Yeah.
What are my favorite x's to pick? -2, -1, 0, 1, and 2. To get the y's, I need to use my base, 3. And it's going to be to the power of the x. So what is 3 to the -2 power?
1/9.
1/9. And then we do it with the next number. Same base, base of my log, to the power of this x. What is 3 to the power of -1? 1/3. Base of my log to the power of this x. 3 to the 0 power? 1. Base of my log to the power of this x. What is 3 to the first power? 3. Base of my log to the power of this x. 3 squared? 9. Yep. We don't want to graph the exponential table. We want to flip it to get the log table. So my x and my y. What would go down the x side? 1/9. 1/3. 1, 3, and 9. What would go down the y side?
-2, 1, 0, 1, 2.
Yes. This is my log table. This is what we're going to graph. Let's start with the whole numbers first. Those are easier to graph. Let's graph 9, 2 first. 9 on the x-axis, 2 on the y-axis. This right here. Yep. Then we're going to graph this point, 3, 1. So 3 on the x-axis, so to the right 3, and up 1. Then I'm going to graph 1, 0, so right 1 on the x-axis, and I don't go up or down at all. Then I'm going to graph this point right here, 1/3 and -1. 1/3 isn't very big, right? Is it positive or negative? So will I graph this to the right or the left side? It's going to be on the right side of the y-axis, but very far? No, it's going to hang out real close to the y-axis. It's positive, so it has to be on the right side, but it's not very far on the right side. What about the next one, 1/9 and -2? Is 1/9 a positive or a negative number? Positive. So will this be on the right or left side of the y-axis?
Barely right.
Barely on the right. So it's going to hug right next to the y-axis. And it's down here. If you remember, we talked about this yesterday. We have vertical asymptotes with logarithms. The y-axis is my vertical asymptote for any parents. This is x equals 0. It's never going to cross the y-axis. So it's going to hug right along here. And then it's going to curve through those points that we plotted. So far, so good? All right. I hope you guys were paying attention to that part, because now we're going to learn how to take a parent like this and do a transformation with A, H, and K. What kinds of things can A do to my graph? Stretches or compresses? Reflects. It can stretch, compress, or reflect. What kinds of things can H do to my graph? Left or right? What kinds of things can K do to my graph? Up and down. I want you to look right up here. This is the transformation form for a logarithm. I will give you this on the test. Use this as a roadmap for where you can find A, H, and K. Where is A in that equation?
The beginning of the equation, right in front of the log.
Right in front of the log. After the equal sign, but in front of the log is where we find A. Where do we find H? In the parentheses. If there is an H value, it will always be inside the parentheses. Where's K?
At the end.
At the end. Inside parentheses?
No.
Never inside parentheses. If you have parentheses, the number inside will be your opposite. Use it to find H.
So it's negative, it's positive.
Mm-hmm.
Okay.
If you don't have any parentheses, but you see a plus or a minus on the end, it's K. It's never H unless it's inside parentheses. So far, so good? All right. First thing I want to do is get our parent graphed. What is the base on this parent? Yes. So here's the base. So off to the side, I'm going to do my exponential table so that I can make my parent table. And it's a thunderstorm.
Wait, I have a question.
Yes.
Why are we making it off to the side? If it's making it off to the side, let's put one down there.
So remember, I have to take the exponential table and I have to flip it to get my parent table. This one right here, we are not going to graph. Third table back. Come on, ladies.
If not, we can wait till D-lunch.
You guys can come in and work on it. I just can't help until lunch.
Are we doing corrections or like?
Corrections.
Oh, okay. That's better. Yeah.
And Yelena, you wanted to take your quiz, right? Sandra, there's yours. You're welcome.
What's maybe?
There's room second or third table back. All right.
Thank you.
You're welcome.
Miss Wolf, I have a question before I start. So for this, when you isolate cosine, would you consider both positive and negative, or just positive?
On this one, just positive. Now, if it was cosine squared, so you had to square root it, then you would consider both positive and negative.
Okay. Thank you.
Good luck. All right. Guys, Mikey had a really good question. She was asking why we were doing the exponential table off to the side. Yes, give me a moment. Why are we doing the exponential table off to the side?
Because we need the exponential table to get our parent.
We need the exponential table to get the parent table, but we are not going to graph this.
I wish they gave us more space, but maybe our space does not look like that.
Understood. My apologies. Needs to be on a separate sheet of paper. What is sine of 5 pi over 3? Unit circle. I want the angle. Sandra, sorry, your corrections have to be on a separate sheet. My apologies. You can just write down the bottom if those are your corrections, and then I've got spare paper if you need it. Yeah. How do I make my exponential table?
On the x side, -2, -1, 0, 2.
Yes. Sorry, it's coming on a separate sheet. My apologies. You're welcome. So down the x side, -2, -1, 0, 1, and 2. How do we get the y side? We're going to use those. You have to do the exponential table off to the side. How do I get the numbers down the y side? Not multiply it by the base. Take it to the power. What is the base here? 3. So it's 3 to the power of -2. 3 to the power of -1. 3 to the power of 0. 3 to the power of 1. 3 to the power of 2. What is 3 to the power of 2?
9.
9. 3 to the power of 1? 3 to the 0?
1.
1. 3 to the -1? 1 over 3. 3 to the -2? 1 over 9. So how do I use that to get the parent for my log now? Flip it. So down the x side, 1 over 9, 1 over 3, 1, 3, and 9. Down the y side, -2, -1, 0, 1, and 2. What was your question?
Now, for the big one, we basically just, after you flip them, you just do the same thing we did for the last one?
This one had the same base. If your base changes, then it's going to be a different number to the power of -2.
Yeah, but the two stickies, you're gonna find the new x and the new y with those numbers switched, basically.
Yes. We're going to take this right here from our exponential table. We're flipping it, and that's what we will use when we go to graph our transformation for the new x and the new y. Let's start off by graphing this one, though. 1/9 -2, so not very far to the right at all, but down 2. 1/3 -1. 1, 0. 3, 1. And 9, 2. Hugs along my y-axis, does not cross the y-axis, and curves through these points. Now I'm going to come over here and look at this transformation. Now I care about what are A, what are H, what's K. Where do I go looking for the A value? In front of the log but behind the equal sign, right? Well, what's in front of the log but behind the equal sign? Yep, right here. A equals 1. We multiply our y's by A. If I multiply all these by 1, does anything change? No. So will this do anything to my graph? Nope. We are going to add K, but my A I don't have to describe in my transformation because it's not changing anything. Does that make sense? Okay. What is my H value?
3.
Close.
-3.
-3. This is the opposite.
So you put that on that side?
It goes on the x side. H always goes on the x side. What will that do to my graph?
Make it flip.
If H is -3, left 3. Remember, H takes things left and right.
Sorry, I forgot to come to the passing period.
That's okay. Yes, and you'll need,
You say a new paper?
yeah, you'll need a spare piece of paper.
Okay, can I just,
Yep, absolutely.
thank you.
So you need to correct it on that spare sheet of paper.
Oh, okay.
What is my h value again?
4, I mean 3,
Negative 3. We add negative 3 to all of these x's. Here I'd pull my calculator out so that I can find my new x's. Negative 3 plus 1/9, when I put that in my calculator, that's negative 2.89. Negative 3 plus 1/3, if I pop that in my calculator, that's negative 2.67. What about negative 3 plus 1?
1.
Close. Negative 2. Negative 3 plus 3. 0. Negative 3 plus 9. Negative 3 plus 9. 6. All right, we've talked about A. That didn't do anything to my graph. We've talked about H. That sent it left 3. What do we still need to talk about? K. What is my K value? Negative 4. What will that do to my graph? Down 4. So that's going to affect my y's. I'm going to subtract 4 from each of these. So my new y values, negative 2 minus 4 is negative 6. Negative 1 minus 4 is negative 5. 0 minus 4 is negative 4. Do you guys see a pattern happening down the y column? Yes. What's the next one going to be? Negative 3 and then negative 2. Before I go and graph those, I need to get my vertical asymptote for the transformation on here. I told you guys yesterday how we find the vertical asymptote for a transformation. It's on the front page. X equals h. So this is going to be x equals what? X equals negative 3. So up and down line, vertical line at x equals negative 3. This is the line that we cannot touch or cross. So I'm going to go plot my new points, my new x, my new y. Negative 2.89 is almost negative 3. It's going to hug right along my asymptote. Same thing with negative 2.67 and negative 5. Negative 2, negative 4. 0, negative 3. And 6, negative 2. Hugs along the asymptote and curves through those points. Last thing we need to do on here is domain and range. Is domain talking about the x's or the y's? The x's. Well, look at my graph. Can I go forever to the left and to the right, or do I run into a barrier? I run into a barrier on the left. That's what this vertical asymptote is doing. I can't go any further than what? Negative 3. Do I have a barrier on the right-hand side? Nope. Negative 3, infinity. My range, on the other hand, is all real numbers. Negative infinity to positive infinity. Our domain for logarithms is going to be h to infinity. We're going to have that barrier, that boundary made by our vertical asymptote on the left. And then it can go to the right forever. I want to do one more example like this. So I want you to look at the second graph. What is the base on this parent? 2. So here's the base. What do I need to do before I can graph that parent? What do I need to do off to the side so that I can graph that parent?
This.
Yep, we're going to do an exponential table off to the side. We're not going to graph this guy. Get my x's and my y's, -2, -1, 0, 1, and 2. What did you say the base of that log was? 2. So it's 2 to the -2, 2 to the -1, 2 to the 0, 2 to the power of 1, and 2 to the power of 2. This number right here is the base. What is 2 squared? 4. 2 to the first, 2. 2 to the 0, 2 to the -1. 1 over 2, 2 to the -2. 1 over 4. Now I can do my parent log. How do I do the parent log? Flip it. 1/4, 1/2, 1, 2, and 4, -2, -1, 0, 1, and 2. I'm going to go graph those now. 1/4, -2, 1/2, -1, 1, 0, 2, 1, and 4, 2. What are we not going to cross on the parent? What does the parent not cross?
0.
0 does not cross the y-axis. Here's the parent. All right, look at the transformation with me. Do we have an a value? -2. We are going to multiply the y's by our a value. Yes, please. What will the negative part of that a value do? You just put it right there. What does the negative do? No, not on an a value. Negative a value. What will a negative a value do? Reflect. This is going to reflect over the x-axis. But my a value wasn't just negative, it was -2. What does the 2 part of it do? Stretch, vertically stretched by 2. What's my h value? 3. So the opposite. So h is 3. What will that do to my graph? It's going to go right 3. Staple it together, and then you can just set it on my desk.
Wait, it's not compressed?
It is not compressed. Only numbers between 0 and 1 compress it. We're going to go right 3. So we're going to add 3 to all of the x's to make it shift to the right. You're welcome. So I can find my new x's now. I would have 3.25, 3.5, 4, 5, and 7. Which piece have I not worked with yet? K. What is K? -1. What's that going to do to the graph? Down 1. So we're going to subtract K off of all of these. So -1, -1, -1, all the way down. Now I can find the new y's. What's -2 times -2? +4 minus 1, 3. What is -1 times -2? +2 minus 1. No. 2 minus 1? 1. 0 minus 1 would give me -1. -2 minus 1 gives me -3. -4 minus 1 gives me -5. Where is my vertical asymptote for the transformation? X equals 3. So over here at 3, I do a vertical line that my transformation is not going to cross. And then I can plot my points. -3.25, 3. Or sorry, no, 3.25, 3. Right here. 3.5, 1 would be here. 4, -1. 5, -3. And 7, -5. Which way is this curving? Thank you. You can just sit it right there. As I go from left to right, the dots that are closest to the asymptote are up at the top. It's going to curve down through these points here. Here's the transformation. What will my domain be?
Domain.
3, and then
3 to infinity, yes.
and then the range will be all the numbers.
Yes. Range is all real numbers. Remember, for my domain, it's going to be h to infinity. Yes, that's fine. There's one last thing that we need to cover quickly. This is on the very last page. Very last page. All right. So they've given me the graph of g of x. They said it is a transformation of f of x, and here's the equation of f of x. We need to figure out how much was added or subtracted to the parent to get this. So f of x, I'm just going to copy from right here. Log base 4 of x. You're welcome. Where is the x-intercept on a parent function? Where is the point for an x-intercept on the parent function? We wrote this down yesterday. It's on the first page. What did you say? It's not 0, 0, but it does have a 0 in it. Look on the front page. Where is the x-intercept for a parent? Where is the x-intercept for a parent? X-intercept for a parent. Yes, 1, 0. This is the parent. X-intercept. 1, 0. My transformation shifted that point up here. How far up was that graph shifted? That's the parent x-intercept. That's for all parent functions. That's always the x-intercept for the parent. How far up was this graph shifted from the parent? How many boxes? 1, 2, 3, 4, 5. Shifts up 5. So what's my k value? K is 5. So what do I need to add or subtract on the end over here? Plus 5. I want you guys to try that check problem. It's just like this, but it has a different k value. The parent x-intercept is still 1, 0. Parent x-intercept is still 1, 0. Let's finish this last one out. This is the function g of x. That's what they've shown me a picture of. Give me just a moment. This is the parent x-intercept at 1, 0. How far did that point shift?
4.
Up or down? Up 4. So what's our k value?
Plus 4.
Yep, it's a positive 4. So how would I write the equation for g of x?
Log 3x plus 4.
Log base 3 of x plus 4. This right here came from here. All right. All we were doing on these and all the ones on the homework that are similar to this, you're just figuring out what k is. So from that parent x-intercept, how far up or down did it go? All right. McGraw-Hill homework is due today. That one was assigned yesterday. Remember, that was the quick one, 7 problems over what we learned how to do yesterday in class. The graphing homework that I just passed out is due on Friday. Graphing homework is due on Friday.